Look, we've got a massive, honestly unspoken problem with how we learn to build the technology that practically runs our world. So today, we're launching a full-on cinematic investigation into the very foundation of software engineering education. We're going to peel back the layers of a truly groundbreaking methodology, a system that's literally designed to completely rewire how you understand code. Because this explainer, it isn't just about learning programming. It's about dissecting the hidden architecture of how to teach complex systems in a way that makes it utterly impossible to look away from.
Seriously, why are coding tutorials so exhausting? I mean, think about your own experience for a second. You want to build this incredible app, you search for a guide, and what are you usually met with? A grueling 2-hour screen recording of someone just typing in a dark IDE. Half the time it's in complete silence, where you've got a monotone voice just droning on and on. It's totally static, it's lifeless. We willingly subject ourselves to these sleep-inducing marathons, desperately trying to memorize lines of syntax, just hoping that somehow the bigger picture will magically click. But let's be real, it rarely ever does.
Okay, let's dive into this, because learning syntax is essentially like reading a dictionary. Sure, you learn the words, but it absolutely doesn't teach you how to write a great story. And the truth is, the really great engineers, they're not just coders, they are architects. When you're just memorizing code, you're merely memorizing vocabulary. You're entirely missing the invisible structural laws underneath the surface, the memory management, the thread prioritization, the elegant flow of data. To truly master the machine, you have to understand the actual narrative of the system.
Chapter 1. The boring tutorial problem.
The core human frustration in engineering education is that we're constantly asked to memorize the how without ever visualizing the why. We just stare at a flat screen of text, completely blind to the beautiful, highly complex machinery operating just a few layers down. It's an outdated model, and honestly, it breeds burnout way more than it breeds brilliance. Think about the old way. Endless syntax, those 2-hour screen recordings, silent typing, exhausting full IDE walkthroughs. It's a slog. But contrast that with the new methodology we're investigating today, pioneered by a channel called Tech SHeaf. They completely replace the static with the dynamic. We're talking deep architecture, visual storytelling, an animation-first approach, and only the absolute shortest, most essential code snippets. Imagine taking something as notoriously dry as memory management and transforming it into glowing, neon and glass morphism 3D interfaces where you can physically watch the data move. It's a total game changer.
Chapter 2. The Master Scripting Engine.
Now, what's really interesting about this is how we can look under the hood of the specific methodology they use to basically hack audience retention. Because if you want to make engineering cinematic, you can't just throw up some pretty graphics and call it a day. No way. You need a rigorously structured narrative engine that literally forces the viewer to stay locked in. So let's walk chronologically through the anatomy of their perfect script. First up, you have the hook. You've got to create immediate emotional tension so the viewer can't leave. Second is the problem, framing a raw engineering challenge as a relatable human frustration. Third, the hidden system. This is where that invisible architecture gets revealed through a powerful visual metaphor. Fourth is the tech breakdown, using only very short, highly animated code snippets. And finally, step 5, the payoff, a completely surprising reveal that emotionally concludes the story. By constantly delaying these reveals and creating little mini mysteries along the way, the audience is hooked from the very first second right down to the last.
Chapter 3. Visualizing the Hidden System.
So once you actually have that narrative engine running, how do you show the viewer what's happening inside the processor? I mean, how do you take incredibly complex, totally invisible logic like the strict 16-millisecond law of iOS performance and translate it into physical motion that anyone can immediately understand? Well, you do it by applying very strict visual constraints. We're talking Apple-style UI, dark, cinematic backgrounds, buttery smooth motion graphics, animated diagrams, neon aesthetics, even fake app UI. And this isn't just about looking premium, right? It's a highly effective cognitive tool. By stripping away all the chaotic clutter of a real code editor and replacing those boring textbook diagrams with glowing 3D interfaces, the viewer is finally allowed to actually see the system working in real time. It completely bypasses the mental friction of just reading text.
Chapter 4. Rules of Audience Retention.
Now, this is exactly where the psychology of learning collides with the uncompromising rules of cinematic storytelling. The goal here is simple, but man, is it incredibly difficult to execute. You have to prevent the viewer from ever feeling even the slightest urge to click away or check their phone. And that requires strict rules. Absolutely no long coding sections, no full IDE walkthroughs, no distracting meme editing. But the absolute most powerful rule of them all, you must introduce tension every 5 to 10 seconds. Just think about the intense pacing that requires. Every 5 to 10 seconds, the viewer has to be hit with a new visual, a smooth animation, a brand new curiosity, or an open loop. And as that last point states, you must always use analogies. This emotional, relentlessly paced visual rhythm is exactly what makes a dry technical breakdown feel like a premium, high-end documentary.
0.1. We are talking just 1/10 of a second. This number represents the ultimate real-world application of these storytelling rules. It's the 0.1 second delusion of how apps like Instagram load photos so seamlessly that it literally feels instantaneous to us. When you take this cinematic scripting engine and apply it to a real-world performance architecture mystery like that, you aren't just teaching a line of code anymore. You are revealing a breathtaking hack of human perception.
Chapter 5. The Real-World Impact.
So, why does completely revolutionizing how we teach software engineering actually matter in the grand scheme of things? Because the overarching mission goes so far beyond just making prettier tutorials. It is about fundamentally elevating the mindset of the viewer. Let this sink in for a second. You don't need another tutorial. You need to understand the machine. That is the massive emotional payoff we're driving toward here. Whether you're a beginner developer, a startup founder, or an engineering student, you should never walk away from an educational explainer feeling like you just memorized a recipe. You should walk away feeling like an architect who can clearly see the invisible laws of the technology sitting right there in their pocket.
And that leads us to the ultimate climax of our structural breakdown today, redefining what we are actually building. True design. It's not just how a system looks, but how it actually works. By merging high-end, cinematic visual storytelling with deep architectural engineering truths, we transcend those old boring methods of learning. We can finally stop reading the dictionary, and we can finally start understanding the story of the system itself.
As we wrap up this explainer, I want to leave you with one lingering, high-tension question to really think about. How does Instagram hack your perception of time to load photos instantly? We've talked all about the architecture of how to tell the story, but the stories themselves are still out there, just waiting to be uncovered. Think about the invisible laws operating right now, at this exact moment, on the device you are holding. The machine is waiting to be understood. I'm your host, and I'll see you in the next explainer.